These problems right here fall under solving equations. And they're actually solving linear equations. Does anybody know what makes this linear? What makes this a linear equation?
Draw it on a graph.
I'm sorry, say that again?
Draw it on a graph.
You can draw it on a graph, and when you draw it on a graph, what's it look like?
Line.
A line, okay? But looking at the equation, what tells us? It's got an equal sign. That's what makes it an equation, yes. What makes it linear? It is a function. We've got lots of functions that aren't linear. We can have a quadratic function, cubic function. Look at my x. What's going on with that x? It's raised to the first power. There's no exponent written. It's not x squared, x to the third. So there is an assumed 1. It's x to the first power. That's what makes it linear. The other thing is it makes a straight line on a graph. And that makes it a big deal. So we've got a couple of things going on in this problem. We have x on both sides. So before we can solve this, we've got to move x to one side. But even before we can start combining like terms, we've got to deal with that 3. What do we have to do with that 3? Good. I've got to multiply it across, and that's using the distributive property. So that is what I'm going to do first, is I am going to distribute my 3. So I have 6x minus 3, and then I'm going to write 2x plus 6 minus 5x. These right here, 2x and negative 5x. What are those called? What kind of terms are those? Like terms. That means they can be combined together. So we're going to go ahead and combine those together because they are on the same side of the equal sign. Okay, so I have 2x minus 5x. That's going to leave me with negative 3x. And then I have 6x minus 3 on the other side. Now our focus is moving the x to one side and moving the constant or the number to the other. So I am going to add 3x to both sides. Okay, so I end up with 9x minus 3 equals 6. I add 3 to both sides, and I'm left with 9x equals 9. My very last step is to divide by 9. So my answer there is x equals 1. X equals 1. Now, if I wanted to check this to see if it works, to confirm that it works, I would take this 1 and I would plug it back everywhere that there's an x. That's what I would do. And that's going to be a very good habit to get into in this class, because later on when we do logs, it's going to be necessary to throw out extraneous solutions. And so getting in that habit of checking is a good habit to get into. Okay, so this is solving equations, solving something linear. The next thing that we're going to do is we're going to solve a linear equation, but it's got fractions. This is a rational equation because it has numbers. You can also have variables in the denominator, but this specific one, we have numbers in the denominator. So what you might think that you need to do first is find equivalent fractions to all of these. And you are correct that you do have to find a common denominator, but we're not going to find equivalent fractions. Because of the equal sign, we are able to multiply everything by a common denominator. And our common denominator is the number that 10 goes into evenly, because that's what's under the 7. That 5 goes into evenly, and that 2 goes into evenly. So what's the number that goes into everything evenly? 10. Okay? So we are going to multiply everything by 10 over 1. Okay? So I have 10 over 1 times x over 2. Okay? Then I am subtracting 10 over 1 times x over 5. And then I've got 7 over 10 times 10 over 1. Okay? Now, if you dealt with this negative sign early, that's probably a better way to do it. My subtraction sign becomes what? So this would become plus, and what would I put in front of that x? A negative. Okay? That is a very reasonable way to keep your negatives straight. Okay? You don't have to do that, but it's a reasonable way to keep it straight, because a lot of mistakes that people make in 144 is that they lose their negatives. Okay? So you've got to remember that this minus belongs to all that. And when we start canceling stuff out here, it's very easy to lose that subtraction sign. So be careful there. So now what I'm going to do, if I've done it correctly, I'm going to get rid of my denominator across the board. So let's see what happens. We are going to cross cancel. How many times does 2 go into 2? Good. 2 goes into 10. Good. So I'm going to have 5x. I've got that minus sign there. Don't lose that minus. 5 goes into 5 how many times? 5 goes into 10. So then I'm left with 2x. Here, my 10s cancel and I'm left with 7. Now, this is an easier equation to solve. 5x minus 2x is 3x, and then I have 3x equals 7. I do get a fraction, but fractions are people too, and we need to love them. We need to embrace it. Fractions are good. Okay? And so our answer here is x equals 7 over 3. And I will admit the check to this is icky, okay, because you're dealing with a fraction. But you can still go back and check it. It's still very possible and very doable to check it. So this is solving equations. Most of the time, students remember solving equations without any problem. If you don't remember solving equations, I very easily can give you some videos and I can give you some problems to work on over the weekend. Okay? The next thing that we're going to do is we're going to talk about simplifying. That's putting everything together. Putting everything together. We're multiplying, we're adding, we're putting things together. Typically, students do just fine with this. This is not an area that I'm overly concerned. Here, I am multiplying 3x plus 5 times x minus 4. This is a binomial times a binomial. And when we have a binomial times a binomial, what do? FOIL. FOIL. And FOIL stands for first. You got it. First, outer, inner, last. Okay? So that means I take my 3x and I multiply it times my x. So I'm left with 3x squared. I take 3x, I multiply it by negative 4, get negative 12x. 5 times x is 5x. 5 times negative 4 is negative 20. Now I'm not done. What do I need to do with my negative 12x and my 5x? Combine them. Okay, so I have 3x squared minus 7x minus 20. Most of us remember that. FOIL is one of those things that we just remember. Okay? For whatever reason, we remember it. Now, this one is a little bit more challenging because it's being raised to the third power. Now, one of the things that I want you to be aware of, an incredibly common mistake with this type of problem right here, and this is wrong, is students want to say 2a to the third plus 5 to the third. And the reason that students remember it this way is because if I had 2a times 5 raised to the third power, then I would give that 3 to everything. I would have 2 cubed, a cubed, and 5 cubed. But look right here. What is that operation compared to this operation? Good. This is addition. What I'm being asked is addition. So the property that allows me to do this down here isn't the same property that I deal with 2a plus 5. I cannot tell you how many times students will write this down. So make that a red flag. Make that a red flag for that. What this means, 2a plus 5 in parentheses cubed, what that means is 2a plus 5 times 2a plus 5 times 2a plus 5. So I've got to use the distributive property on this multiple times. So the first thing that I'm going to do is I'm going to multiply 2a plus 5 times 2a plus 5. I'm going to use the FOIL method. That's exactly what I'm going to do right there. 2a times 2a is 4a squared. 2a times 5 is 10a. 5 times 2a is 10a. And 5 times 5 is 25. So I'm left with 4a squared plus 20a plus 25. Okay? Now, I've got to use the distributive property to multiply this 4a squared times both of these, 20a times both of these, and 25 times both of these. Okay? Students typically don't make a mistake on how to do it. They're like, okay, I've got to give all those to everybody, and everybody's got to be multiplied by everybody else. What happens is students make a computation error, or students lose an exponent. So if you miss this one, it's likely because of a small computation error, so just be careful here. So I am going to use colors. So the first thing that we're going to do is we're going to do 4a squared times 2a and times 5. So I have 4a squared times 2a. Okay, and if you just go to 8a to the third, I'm totally fine with that. Like if you skip that step where I'm writing 4a squared times 2a, that's okay. Then I've got 4a squared times 5. So I'm going to do 4a squared times 5, and I'm going to get 20a squared. Okay? So I've taken my 4a squared and I've multiplied it times my binomial. Now, I am going to take 20a and I'm going to multiply it times 2a and times 5. So I'm going to have 20a times 2a, and that is 40a squared. Then I'm going to have 20a times 5, and that is 100a. Okay? Now, the next thing that I have to do is I have to multiply 25 times 2a and 25 times 5. So I have 25 times 2a, and then I have 25 times 5. Okay? 25 times 2a is 50a. Whoops, I didn't write all that down, did I? 25 times 5. Is that better? And that's 125. Okay? So you have to be super careful here, making sure that you account for every single term. Then our last step is to simplify all this. I don't have anything to combine with a to the third, so I'm just left with 8a to the third. No like terms. Then I have 20a squared and 40a squared. So I'm left with 60a squared. 100a and 50a. Okay? And then I've got 125. Okay? So again, we typically don't get confused by this because of what we have to do. It's in this step right here, we just missed something. Okay, and it's okay to use lots of different colors. That's fine with me. Okay? Now, The directions for this say to factor completely. Factor completely. Now, anytime that you factor, the very first thing that you're going to want to do is you are going to want to see if there is a GCF. And that means, is there something that's common to every single term? Is there something that's common to every single term? So the first thing that I look at when I'm looking at the GCF is I look at my numbers. So here I've got a -4, here I've got a -2, and here I've got a -6. -4, -2, and -6. What number goes into all three of those? 2 does. And I would say -2. Now, if you only take a 2 out, you're still going to be correct. But a -2 can come out of all of it. Okay? So I am going to pull out a -2. Then, the next thing that I'm going to look at is I am going to look at the x to the third, I'm going to look at x to the fourth, and I'm going to look at x to the fifth. And I want to know how many x's can I pull out of every single term. So what I'm actually looking for is I am looking for the x with the lowest exponent. What is the lowest exponent? 3. So I can pull an x to the third out of every single one of those. So that is my next step. Then I'm going to look at y to the fourth, y to the third, and y squared. What can come out of each one? Y squared. So -2x to the third, y squared is my GCF. That's my GCF. That's what I am pulling out of every single term. You have to look at your number, you have to look at your x variable, then you have to look at your y variable, and you need to look at them separately as you are doing this. So now I ask myself, -2 times what gives me -4? 2. Okay. X to the third times what gives me x to the third? 1. Now, a lot of people will say nothing. A lot of people will say x to the third times nothing gives me x to the third. That's not true. What's x to the third times 0? 0. Okay? So it's actually x to the third times 1. Now, we don't have to write that 1 down because we've already got a -2, and then we're going to have a y in there too. But just be careful, don't say nothing, because you're actually multiplying it by 1. Okay, y squared times what gives me y to the fourth? Good, excellent. Y squared. Okay, now let's look at the next one. -2 times what gives me -2? 1. You may want to write a +1 there. You don't have to, because anytime we have variables with no number in front of it, there's an assumed 1. A lot of times I do, just because I like to keep everything straight. Okay? So now I've got x to the third times what gives me x to the fourth? Good, and it's just x to the first, but we don't have to put that 1. Y squared times what gives us y to the third? Good. Okay, and we're going to do it one more time. -2 times 3 gives me -6. X to the third times x squared gives me x to the fifth. Y squared times 1 gives me y squared, and I don't have to write that down. So this is my final answer here. How many of you paused to see if this trinomial could be factored? Did anybody pause? Good, good, okay? It can't be factored, but you do want to pause and look at it and say, oh, I need to decide if that can be factored. And can you tell me how you did that? How did you decide it couldn't be factored?
Just try to see if there's anything else they had in common.
Okay. Good. Okay, is there anything else in common that they had for all three of them? That's good. Now somebody else raised their hand too. It's a trinomial.
I was going to combine the 2y squared, but then you can't combine that with anything else.
Correct.
You have like multiple
Okay, because you're correct. All your exponents are different. Did anybody multiply the 2 times the 3 and get 6? Because it was a trinomial? Anybody think about that? It's okay if you didn't. So my product, because it's a trinomial, could have been 6. My sum was 1. There's no 2 numbers multiplied together that give me 6 and added together give me 1. Now we'll review this process in just a second. This was definitely had a lot of variables and stuff in it, so it was very much a greatest common factor factoring problem. But once you get a trinomial in there, you always want to start thinking to yourself, can this be factored even further? Okay? So it's a good habit to get into. Now, the next one is factoring by grouping. Factoring by grouping. Typically, students don't have any trouble with factoring by grouping. Typically, they're like, ooh, I like these kinds. Okay? So with factoring by grouping, the first thing that you do is you look and see, is there anything that goes into those first 2? 2 and x. Perfect. So I'm going to pull out that 2 and I'm going to pull out that x. And I'm left with z plus 3. Thank you. Okay? Now I look at the next 2. Is there anything that can come out of both of those? Y. Did I forget something on this too? Okay. So on the thing, when I gave it to you, it was correct, right? Awesome. Yippee. I've already ran out of all my mistakes today. I don't have any left. Okay, so I'm going to pull out my Y. And I am left with z plus 3. Okay? So this factors to 2x plus y and z plus 3. Okay? And that is factoring by grouping. What has to happen for us to factor by grouping? What has to be the characteristics?
The 2 things in parentheses have to match.
Good. The 2 things in parentheses have to match. When we start, you've got to have 4 total terms. Both of those things have to happen or we can't factor by grouping. Good. Good job. And like I said, typically, that's not one that students yell and scream about. Okay. Now, and again, this is another one that students typically don't yell and scream about yet. Okay? Now, this is a quadratic. What makes it a quadratic is it's raised to the second power. We are going to do a lot with quadratics once we hit chapter 3. A quadratic in standard form is ax squared plus bx plus c. You may or may not remember that back in your brain, and it's okay. The thing that makes this factoring problem easier on us is that there is a 1 in front of that x squared. And when there's a 1 in front of that x squared, we can factor pretty quickly. What we do is we look at this number right here, our b value, and that is going to be our sum. So my sum is -2. We look at this value right here, and that is our product. So I am looking for 2 numbers. When I multiply them together, I get -35. And when I add them together, I get -2. There is some guess and check involved. Okay? We're guessing, we're checking, we're going back and forth. But when I've got an A as a 1, meaning I'm just left with x squared, there's no number in front of it, then I can do it a little bit more straightforward. Okay? What are my 2 numbers here? -7 and 5. Okay? So because I've just got the 1, because there is a 1 right here, I can just write that down. X minus 7, x plus 5. Okay? And then I'm done. I factored. That's it. Okay. I am going to skip the next one, and then we're going to come back to it. Because I want you to look at the difference between this one right here and this one. Okay? What's the difference? we have a number in front of the x squared. And this is where students across the board, from algebra in 8th and 9th grade all the way to calculus 10, they just forget. They just don't want to factor these types of problems. Okay? The difference with this is that we have that 4 in front of the x squared. Now, there is the box method. There is the x method. There is a new method where you find your intercepts and then you work backwards from your intercepts that I actually hadn't seen before. So there's all sorts of different ways that you can factor. I'm going to show you one that turns it into a grouping method because I think that's the most straightforward. If you have a factoring process and it is mathematically sound, absolutely. You don't have to adapt to my way. You do need to make sure it's mathematically sound because I promise you there's not more than one answer to these problems. There is one correct answer when you're factoring, so you've got to make sure you're getting that. And I'll look at your method with you if you want to talk about it. So, the first thing that we are going to do with this method right here is we are going to take our A value and we are going to multiply it times our C value. Okay? This is the AC method. What is 4 times 15? 60. And that is my product. You have to multiply your A and your C together to get your product. My sum is still my B value. My sum is still my B value. What's my B value? 16. Okay, so I am still looking for two numbers multiplied together give me 60 and added together give me 16.
6 and 10.
6 and 10. So my numbers are 6 and 10. Now, this is where students get confused, and if you make it to this step, you're done. You're good. You're going to slide on through to the end. Because I have a number in front of my x squared, my answer is not x plus 6 and x plus 10. That's where students make mistakes. What you have to do is you've got to split your B value. Is 6x plus 10x still 16x? Yes, my value has stayed the same. I've just split it. So what I have now is 4x squared plus 6x plus 10x plus 15. Now I can use the grouping method to solve it. Okay? This is less guess and check than the box method, the X method, and the other method, where you have a denominator and stuff. Okay? Now again, box, X, and the denominator one, they're all mathematically sound. They're kind of tricks to help you factor. So when you memorize a trick, you can't always go back and find the correct answer. So if your method works for you, then you can do it, but you've got to make sure it's mathematically sound. Okay? At this point right now, I'm going to pull a 2x out using the grouping method. Okay? Here I'm going to pull a 5 out. And my final answer here is 2x plus 5 and 2x plus 3. Okay. These problems right here, when you've got a trinomial, and trinomial means a group of 3, and you've got an A value that's not 1, those are the problems that students tend to struggle with the most. Okay? So just kind of keep that in the back of your mind that this may be what you need to practice the most. Okay, now I'm going backwards. Can I go backwards? Is that allowed? Okay. This is a special product. A special product. This is a special product that you've got to be able to identify when you're factoring. Any ideas what this is? Yes? It's difference of squares. That's what it is. And there's multiple reasons that it's difference of squares. Okay? 36 is a perfect square. What's the square root of 36? 6. A squared is a perfect square. What's the square root of a squared? A. 25 is a perfect square. 5. B squared is perfect. B. Now, all of those things have to be perfect, and you must have a subtraction sign. Okay? So 36, A squared, 25, and B squared all have to be perfect, and it has to be a minus sign. If you don't have that minus sign, you can't do it. It's got to be subtraction. And I take the square root, so I have 6A plus 5B, and then I have 6A minus 5B. Okay? And students tend to remember that. They tend to remember that. Unfortunately, they also like to apply this to the same thing. Okay? 36A squared minus 25B squared, that's one thing. And that can be factored. 36A squared plus 25B squared, that can't be factored. And students like to remember this and apply it to that. And that's wrong. That can't be factored. It's got to have the minus sign or it doesn't work. Okay? And that's a special product. You don't have to remember the name. It's difference of perfect squares. Okay. Now, this is another trinomial, and this is what we call a perfect square trinomial. I typically don't look and see if something's a perfect square trinomial. I don't memorize this. I just factor this using the AC method. I multiply the A times the C, and I start looking for my numbers. But I do like to show this because some of you may identify it. What is the square root of 16x squared? 4x. What's the square root of 25? 5. Okay? What is 4x times 5? 20. Double that. 20x, actually, yes, it is 20x. Double 20x. 40x. This is a perfect square trinomial. So this factors to 4x plus 5 squared. Okay? But, like I said, I don't look at that and look for a perfect square trinomial. What I do is I go ahead and use my AC method. So I'm going to multiply my A and my C together. So I'm going to have 16 times 25. When that turns out to be 400, I might think, oh, this may be a perfect square trinomial because 400 is perfect. But I might not, too. I mean, I just might keep going using my AC method. So 16 times 25 is 400. What's my B value? 40. So 20 times 20 and 20 plus 20 are my two numbers. Very often, that's when I figure out it's a perfect square. It's not until that point right there. Okay? Because then we've got several different red flags, and it doesn't matter. You don't have to ever identify that this is a perfect square trinomial because this method, your AC method works. Okay? I factor the first two. So I take out a 4x. I'm left with 4x plus 5. Okay, this time I take out a 5. Whoops. Okay, and I will tell you there's been many times it has not been until I've written this down that I've realized it's a perfect square. Okay? And if you leave it as 4x plus 5 and 4x plus 5, you're fine. But you also can do it 4x plus 5 squared. Okay? Factoring is when we are taking things apart. We are breaking them down. We've got it all put together and we're breaking it down. Simplifying is when we're putting it all together. So you have the term solve, you have the term simplify, and you have the term factor. Okay, and those are three terms that are used in math quite a bit, specifically algebra. Now, like I said, factoring is probably the thing that you need to review the most. And I've uploaded some videos already on how to help you with factoring. Solving equations is secondary. Okay, you do want to kind of go in and make sure you know how to solve equations, but it is secondary. So factoring is kind of the big stuff. What I'm going to do now, and I should have time to do a couple of these, is where we are solving something and it's not linear. So here I am solving something that is a quadratic. And what makes it quadratic is it's raised to the second power. Now we're going to do all sorts of stuff with quadratics. We're going to put it in vertex formula, we're going to graph it. We're going to find the intercepts, we're going to find the y-intercepts. We're going to identify the vertex. I mean, we are going to do so much with quadratics that you're just going to dream about quadratics. Okay? But you have in the past solved quadratics. And this particular quadratic right here can be solved by factoring. Okay? So I look at this, x squared minus 11x plus 28. So what I want to do, this can be solved by factoring, is I factor it. My sum is negative 11. My product is 28. So what are my two numbers? Negative 7 and negative 4. Good. Why are they negative? Good, because of the negative 11. You got it. Okay? Then I set each one of these equal to 0, and I solve. So I have x equals 7 and x equals 4. Now again, we're going to do lots of stuff with this. But what that means is when I graph this quadratic, it's going to cross the x-axis at 7 and 4. Okay? It's going to cross the x-axis at 7 and 4. Now, our next one, I have x minus 1 times x plus 2 equals 42. Now, I'm hopeful that you wouldn't make this mistake, but some students will do x minus 1 equals 42 and x plus 2 equals 42. But we can't do that. We have to have our quadratic, or any polynomial that we're solving that's not linear, set equal to 0 before we can solve it. So I have to FOIL this. I have to FOIL it. So I'm going to have x squared plus 2x minus 1x minus 2. Is that right? Okay. I can simplify that to x squared plus 1x. And I've got to move that 42 over. Okay? So then I'm left with x squared plus 1x. I feel like I've made a mistake here. 2x minus 1x is going to be 1x. I'm good? What are my numbers?
There's not supposed to be a -2.
Negative 1 times 2 is negative 2. Oh, I know what I did wrong. I wrote down x minus 1. And my problem in my book is not that. Okay, so we're good. We're still good. We're still good. Okay. So x squared plus 1x minus 44 equals 0. Now, this can't be factored. Okay? Two numbers multiplied together that give me negative 44 are negative 11 and 4, or 4 and negative 4 and positive 11. We can do 22 and negative 2, or negative 22 and positive 2. But none of those are going to give me the right sum. Okay? So to do this, we would either have to use quadratic formula or completing the square, which is okay. We can use quadratic formula or completing the square. It does get a little messy because you're dealing with rational numbers. Okay? The same is true, and we're going to spend time doing that. Okay? We're going to relearn how to do that. This one is also one that you can't multiply two numbers together to get 9. That also add to get -4. Okay? And so this one is a great one for completing the square. And again, that's something that I'll teach you. It's good if you've had a little bit of background on completing the square, but I'll remind you. This one is a good one to use for the quadratic formula because our a value is 3. And that makes a big difference. So, in summary, I have put up already some factoring stuff under review. On Tuesday, we're going to start chapter 2. So anything that you need to look over, if you need to look over solving equations or you need to look over factoring, this is a great opportunity to do that. Okay? Have a great weekend. I'll see you on Tuesday.